Today I'll work on this excavation takeoff project, and this project is given as you can see. These drawings are provided, so you can get these drawings to get a reference. Now, to start with this project, we go to the site plan, and the site plan you would need to notice for the levels, and if the levels are not same, then you have to take the average of these levels. So that's step number one. And in the calculation of excavation, there is two main items that we need to calculate. The first one is the exact amount of the basement per se, and this includes the measurement. This goes to the measurement, which is 7.4, and you have 8.1. So you don't do a center line for these ones, you just 7.4 both sides, this side and this side, and 8.1 this side and this side. You just add them up, and that will be the perimeter for the footing, and then we multiply them by the depth of the footing. That is one part. Now the second part is, of course, you can't go to this excavation unless you be a bit wider, and this is the wider part of it, in which we will need to, there's certain rules for these ones, the distances for these, and this is called perimeter excavation. I'll explain this as we go to the section. So these are the two parts that we need to do the calculation for. Now, to elaborate on this, we will do the section and go through the. So this is our plan, and we need to, as you can see, the shaded part is the foundation wall. This will be the foundation wall, and of course this is meant to be the footing, and this is the excavation. So if we take a section, as we can see here, so this will be the look of the section. So we need to do the calculation for this part of the excavation, which was just called the bulk excavation, and then we also need to do the calculation for this part of the calculation of excavation. This is called the perimeter excavation. Now, first of all, we need to start with the calculation of the depth. So if you go back to the plan here, and you would see that the level are given as, this is the top level, 256.45, and also it says here suggested the grade is 256, and then the lowest top footing is 255.25. so that's the top of the footing. So this is the footing, and this is what they mean by the top footing. Okay, so it is straightforward here. We can do the calculation by, for that part will be, it will be the top of the footing was 256.45 minus the top of the footing, this part was given as 255.25, and this will make 1.2 meters. But we need to go to the bottom, to this part. We need to go to this part, and this footing being given as 400 by 150 thickness in the drawings. So if you go to the drawings, you'll see in the section part here, it says sorry, it is in the, you could see this in the, you have to search for it. Sometimes it's in the specs, so just be careful. So this is 1.2, and this measurement being 150. So this, the total from this point, the grade until the bottom of the footing will be equal to this part plus this part. And the first part is already calculated as 1.2 meters, and this part has to be added as plus 1. Sorry, it is 100 millimeters, of course. So this will be 0.15. So the height will be equal to the depth is equal to 1.35 meters. So we can say this is equal to 1.35 meters. So anyway, this is for the depth part calculation. Now we need also to make sure that to find a way in which we do the calculation for this part, because this part is a bit harder to calculate. So I need, for that part, I need first of all to do the calculation for these distances, distance from here to here, which is called bottom of the footing, and this part, which is called the top of the footing, that's for the excavation. So let's move to the so this is our sketch actually. This is the building that we have. So we need to do the calculation. This part, we'll start with this part calculation. So for this part, the equation is the width of the footing, which is, so I'll say this is the bottom of footing calculation. The equation will be the footing, which is 400 millimeters, minus the foundation wall, which is 200 millimeters, divided by 2. This is an equation. So this will become 200 divided by 2 is equal to 100. That is millimeters and is equal to 0.1. So if you want, you can update this part to be equal to 0.1. Now this part is normally called the pay line. This is what the contract will pay for, this part. So this is usually 600 millimeters. So to get the bottom, or the entire bottom here of footing, so we'll have 600 millimeters plus the 100 millimeter that we just calculated, and is equal to 700 millimeters and is equal to 0.7 meters. So that is first part of the puzzle. So this is equal to 0.6, so the total is equal to 0.7. Now for this part, there are many factors involved here. The type of soil is what will decide this inclination for the excavation. And the soil that we have for this project, again we go back to the project itself. So the project here says that the type of soil is given in the specs, in the specification. Say it is a clay. So for clay, this inclination is defined by these rules. It says if you have a clay, then the inclination is a 3. For each 3 vertical, you will have to go 1 horizontal. Meaning that if this is depth 3, the depth is a 3 here, then this will flare only 1. That is the meaning. So based on this we'll do, and of course, so yeah, so let's go back here. based on this calculation, so I need to, so I say it is, now let's start with the calculation of top of the footing calculation. So the flare is 1 to 3 is equal to, now the depth I have here is equal to 1.35 meters. So how much will be the flare? How much is this distance, meaning this distance? Okay, so based on that, x will be equal to, sorry, I make this in detail so that will not be confused. 3x is equal to 1.35, so x will be equal to 1.35 divided by 3, and let's do the numbers here. 1.35 divided by 3 is equal to 0.45, that is meters. So I mean this is equal to 0.45, and because I know this distance already, being 0.7, so the top of the footing, the top will be equal to 0.7 meters plus 0.45 meters, and this will be equal to 1.15 meters. So this is the other distance they have. So now I have the top distance and the bottom distance. The target is, I would like to see how much is the average, because I can't calculate this shape. So instead what I will do is I'll do the average of this shape, and the average of this shape will be something like this. This will be the average. So I need to know the distance. The average distance is equal to how much. Now because this shape is not normal shape, it is like that, so we suggested to do the average of the width. Of course the average of the width will be is this one, and the average rectangle for that one will be something like this part. So to calculate the average distance here, average distance between top and bottom, average distance will be equal to 0.7 at the bottom plus 1.15 at the top, divided by 2, and this will give us a distance equal to 0.92 something. 0.7 plus 1.15 divided by 2 is equal to 0.7 plus 1.15 divided by 2. 0.925. So we will round this up to 0.93 meters. Okay. So now that we calculated the average distance, now we'll start to do the real calculation for that part. So now I have this distance is given. I calculated already this distance to be 1.35, and I have this distance equal to 0.93 meters. All I need to do is I need to work on the center line. I need to find out the center line. The center line here need to be calculated. The rule to calculate the center line is is the perimeter, which is this one for the footing, for the wall foundation. And the perimeter, if you will look at the drawings again, just remind you, is, if you look at the sketch, is given as 7.4, this measurement, and the other measurement is 8.1. So straightforward. This is a very straightforward rectangular shape, and that part will be based on our previous understanding. Is we have 8.1 multiplied by 2, these are two sides, plus 7.4 multiplied by 2, and we to get the perimeter is, this is the entire perimeter, there is no equations other than that, plus, now this part, the calculation for this part is equal to 8 times, this is rule, multiplied by half of the average that we just calculated, this one, which is 0.93. So if we do these numbers, we'll come with the value of 34.72 meter length as a perimeter. Now so far we got this also. So these are just numbers. We'll get them into the Excel sheet, but we'd like to get some sort of an understanding for how did we do the calculation, because you will not have access to Excel sheet during the test, so you need to do the calculation manually yourself. That is one. Now the second thing that I would like to touch on here is in the calculation for the weeper tile. The weeper tile sits here most of the time. We'll do the calculation for the center line of that one too. Now the calculation for the perimeter of the bulk calculation, which is inside the basement, is only this part, by the way. So it is straightforward as the 4 sides perimeter. Just add the perimeter 8.1 plus 8.1 plus 7.4 plus 7.4. Now let's talk about the weeper tile now. Now for the weeper tile part, again, let's take a look at this, and we're talking about this guy. I would like to know what is the center line calculation for this one. Now the weeper tile is given as 100 millimeter in the drawings. Let's say it's a 100 millimeter. It's always attached to the, or it is close to the footing. So the calculation for the weeper tile is same goes the perimeter. The perimeter here, which is same. We have 8.1 meters multiplied by 2 times 2 sides, meaning plus 7.4 meters 2 sides. This is a plus. We'll have to add the projection, which is this part, and half of the diameter of the weeper tile. Okay, so that distance is, maybe we should have done the calculation for that one, that part, before this part. So let's say this is the equation says 8 times multiplied by this distance, which is, I will call it distance, only distance. Now the distance calculation is equal to the projection, which is, in this case, this projection is 0.1 here is equal to 0.1, and I need to get also the half of the diameter of the weeper tile, so 0.1, and the weeper tile is 100 millimeter, means 0.1 divided by 2, so the answer distance is equal to 0.15. So going back to our calculation here, if we apply this equation, so it will be equal to 8.1 multiplied by 2 plus 7.4 multiplied by 2 plus 8 times, there is no half here. The equation doesn't have any half here because that is multiplied by 0.15 is equal. So from this we get a value of, let's do the numbers here, so 8.1 multiplied by 2 is equal, plus 7.4 multiplied by 2 is equal, plus 8 multiplied by 0.15 is equal. So it is equal to 32.2 meter long. So that's a calculation for the vapor tile. So with this one, we'll end the explanation part of it, and then we'll move on to the Excel sheet to put these numbers. So just keep in mind the numbers, so we could go back and forth to this to these sketches and the calculation to remind you about the way how we calculated these numbers. And you have to know these numbers, how they were calculated, because you have to manually do this calculation and the test on a piece of paper, not on Excel sheet.